Okay, last lesson for this unit, everybody. Congratulations getting to this point. This lesson, I think you'll find if you did well with the other 4 lessons or you're starting to understand the other 4 lessons, this lesson here will really just kind of assess, how far you've come because we're just putting it all together and working on some application type questions. So there's going to be essentially nothing new here, okay? But um, we're going to just look at some applications of it, okay? And it's going to test our knowledge of what we've learned so far for sure. So, example 1 here, all right? It says determine a formula for the perimeter of this triangle in terms of x. Okay, a formula for the perimeter. And then it says to simplify. Okay, so we learned all about simplifying for this entire unit. So let's see what we come up with when we come up with the perimeter, and then we'll see what needs to be simplified. So first off, it's asking for the perimeter. So write down the formula for the perimeter of any shape. You have to add up all the sides. So the perimeter of a triangle is simply adding up side 1 plus side 2 plus side 3. Okay, so I'll just label these side 1, side 2, and side 3. Okay, well, side 1 is actually an expression that is x plus 2. Now remember what I said back a couple lessons ago. When you substitute in an expression into a formula, you always have to do it in brackets. So get in that good habit, okay? So x plus 2 will be replacing s1, and it should go in brackets, plus bracket x plus 5, and then plus bracket 2x plus 3. Okay, so this is, if this question were out of 2 marks, let's say, this would be 1 mark, right? You would get 1 mark to this point. We found an expression or an equation, a formula for the perimeter, okay? Perimeter equals x plus 2 plus x plus 5 plus 2x plus 3. But the other mark, if this is out of 2, would be to simplify. And hopefully you can look at that now and say, oh, I've got some like terms that I can collect to simplify this down a little bit. So let's do that. When we're adding and there's brackets involved, do the signs change at all inside the brackets like they do when you subtract? If you can remember back to a couple lessons ago. Should the signs change at all, or can we just drop all these brackets now because there's plus signs in between? Hopefully you can remember that because we're adding, we can actually just drop all these brackets. So I can just write this as x plus 2 plus x plus 5 plus 2x plus 3. Okay? And now let's go about and collect like terms. I can collect x plus 2x. Then I can collect positive 2 or plus 2 with plus 5 and then plus 3. Okay? And our last step to simplify this would be to collect the like terms. We've grouped them together here. Now let's just collect. So we have x plus 2x. Remember that there is a 1 in front of each of these x's. If in case you forgot, write them in. So we have 1 plus 1 plus 2. That is 4 x's altogether. And 2 plus 5 plus 3 is 10. Can we go any further than this in simplifying it? The answer is no. There are no longer any like terms. I now have just found a formula, a simplified formula for the perimeter. So instead of using x plus 2 plus x plus 5 plus 2x plus 3, I created an equivalent an equivalent simplified version of that where it's just 4x plus 10. Okay? So that's a simplified version. Now let's answer question B. Use your formula to find the perimeter when x equals 2. Okay, so this is nothing new to us. We just have to substitute 2 in for x. So perimeter equals 4. Now instead of x, put bracket 2, 4 times 2, plus 10. Our final answer then, the perimeter is 18. And we should put a therefore statement. Okay, so therefore the perimeter is 18. And don't forget your units here, right? We're using centimeters. Don't forget that. Okay, that's the whole point of a therefore statement, is you want to be explicitly clear as to, things like what the units are or what you actually found. In our case, we actually found the perimeter. Okay, so the perimeter is 18 centimeters. Okay, so if you want, you can pause the video at this point, try this question by yourself. Both questions A and B, cover my answer, and see if you can get it right. I'm going to move on to example 2. Okay. Explain how this model shows that the length is 2 times the width and 3 times the width, and the height is 3 times the width. Okay, so we need to do some labeling here, right? Because I have x, 2x, and 3x. Well, they're basically telling me, right? They're saying, explain how this model shows that the length is 2 times the width. Okay, well, if my width is x, okay, so we'll call this my width down here. It says that my length is 2 times the width. Well, that makes sense. If this is now length, it's 2x, right? 2 times x, or 2 times the width. So that's my length. And then my height is 3 times the width. 3x. Okay, so this is going to be my height. So the width is always is your horizontal line. Your length is kind of your depth when you're looking at a 3D drawing. Okay, and your height, of course, goes up and down. Okay, so let's answer the question. It says, explain how this model shows that the length is 2 times the width and the height is 3 times the width. Well, we can say something like, if width is represented by x, then 2x is 2 times the width, and 3x is 3 times the width. Okay, hopefully that makes sense to you. You have x, you have 2x, you have 3x. The 2x is just double the width and the 3x is triple the width. Okay, so that's just a little communication question. Let's go to an application style question. Determine a formula for the volume. Simplify your formula. Okay, so if you didn't know, this is a rectangular prism, everybody, right? It's a rectangular prism. It's a 3D shape. And we know that 3D shapes have volume. Okay, so if you didn't know what the volume was for a rectangular prism, what could you do to figure it out? Google it. Okay, and you will find that the volume for a rectangular prism is length times width times height. Okay, length times width times height. So we have to find a formula with our variables and our terms in there, okay, and then simplify it. So let's do that. Okay, if I know that my length is 3x, or sorry, 2x, my height is 3x, and my width is x, just sub all of those in to my letters in my formula. And remember to use brackets. Always, when you're replacing a letter in a formula, use brackets, okay? So 2x, now it's times my width, which is x, times my height, which is 3x. There's my formula. That's 1 mark right there. Okay, you do that and you get 1 mark. How do you get the other mark? Well, you need to simplify this. Okay, I ask you now, because I know you're probably thinking, oh, maybe we can collect like terms. Can you collect like terms here? The answer is definitely no. You cannot. Okay, why can you not collect like terms? Because there are no plus or minus signs separating the brackets. So for example, if it said 2x plus 3x, absolutely you can collect those like terms. But do we have addition in between? No. Okay? We have multiplication. So we have to go to our multiplication rules. And our multiplication rules say that you can multiply the coefficients, so 2 times 1, that's really a 1x, times 3. Okay, so you can multiply the coefficients together, 2 times 1 times 3, which is 6, and multiply the variables or the letters together. So x times x times x. Well, what's x times x times x? What's a simplified way of writing it? It's 6x cubed. And did you have to write this step here? No. As long as you can get to this point, okay, you'll get the other mark. Okay, you do not have to write that middle step there. An easier or an easy way, I told you in section 5.3, I told you that an easy way to multiply when you're multiplying variables is you can just add their exponents. So each one of these x's actually has an exponent of 1 on top that you don't write, but it's understood that all of them have an exponent of 1. 1 plus 1 plus 1, that's where your 3 comes from. Okay? X times x times x is x cubed. Just like if I asked you, what's another way of writing 3 times 3 times 3? Well, you could write it as 3 cubed, 3 to the power of 3. Okay? Same thing as if you use variables instead of numbers. Okay? And that's it for that question. We have simplified it. There's nothing more you can do. Okay? There's absolutely nothing more you can do here. And I do just want to make sure that I write volume equals 6x cubed. Okay? And now let's answer kind of the type of question that always follows up. Once you find the formula, it'll ask you to substitute a value for x. So let's substitute in x equals 3. So we get volume equals 6. Now instead of x, I'm going to put a 3 in brackets. Remember, always replace a letter with brackets in a formula. And then cubed. Follow BEDMAS here, please, everybody. Okay. Can you do 6 times 3 yet? No. You need to do exponents first. So do 3 to the power of 3 on your calculator. So you get 6. What's 3 to the power of 3? 3 times 3 times 3 is 27. Be careful, it is not 9. I can't tell you how many times students will put 3 to the power of 3 is 9. No. 3 times 3 is 9. 3 to the power of 3 is 27. Okay, it's 3 times 3 times 3. Final answer, 6 times 27. Okay, 6 times 27. So do that in your calculator there, and I believe you will get 162. Okay, yep, that is correct. Okay, 162. So that's what your volume is, but then of course give a therefore statement. Okay, so therefore the volume is 162 centimeters. Okay, now when you're finding volume in your units, do you remember, do you put square, do you put cubed, or do you just leave the units as just centimeters when you're finding volume? Okay, hopefully you can remember this, but it's cubed. You've definitely done this in elementary school, that volume is always units cubed. But in case you forget, okay, I'll just write this out for you. Volume is units, whatever your units are, cubed. Area is whatever your units are, squared. And perimeter is just your units to the power of 1, but you wouldn't write to the power of 1. Okay? So if it's a volume question, make sure you have cubed at the end of your units. If it's area, make sure you have squared at the end of your units. And if it's perimeter, you just need to put your units. Okay, that concludes this unit, everybody. Please try these questions on your own. Cover my solution, see if you can get the answer. Okay, and you'll be ready to start the homework here